Hi guys, friendly neighborhood math teacher here. I obviously am not in class with you today. I'm sorry. I'm not feeling so well today, so I'm gonna go home and rest. I think I got that flu that's going around. Didn't want to get you guys all sick before Christmas. So be good for your sub, please. Go tell her hello. Tell her thank you for being here. Okay, good. Let's go see what we can get through together today. First of all, as it says, how is your Quadratics connections packet? So we had that white packet. We had 4 of those done together, and I'm just taking a wild guess that you might have some questions on these last 4. So I am just kind of picking one, honestly, because I'm not here to answer questions. I'm just going to pick one. I think I'm going to have the most questions on problem number 6. So I'm sorry if that's not yours. We'll just go with it and see how it goes, right? So let's try problem number 6. There, can you see better now? Okay, so problem number 6 says 1/2 x squared minus 4x plus 8. And you know that we have been finding our axis of symmetry first. I hope you remember the formula for that little axis of symmetry. It's not the entire quadratic formula, it's just that little bit that doesn't have the square root in it. So our axis of symmetry is opposite of b over 2a. And I hope you look and see that we have this in descending order already, so we know our a, b, and c. A is 1/2. B is not just 4, but it is -4, so kind of keep in mind about the negative. And C is 8. All right, so opposite of B is a positive 4. 2 times 1/2 is just 1, so you have 4 divided by 1. That means X is 4. That's that axis of symmetry line. And by the way, you remember you're having a quiz on this stuff, so that is something that you're going to need to remember in the next few minutes, opposite of b over 2a. Now we'll go find our vertex. Remember, the vertex is the highest part if it's an upside down parabola, or it's the lowest part if it's a regular right side up parabola. Do you remember how to figure out if it's an up parabola or a down parabola? We look at the letter A, and A is the number 1/2. Since it's positive, I know that my parabola is going to go up this way, and that means my vertex will be a maximum or a minimum. It's going to be a minimum. Okay, let's go do that. So I know that my vertex will already have x is 4. Now we just have to go find y. We go put it back in the original equation. 1/2 4 squared minus 4 times 4 plus 8. Remember, square the 4 first. 4 squared is 16, and half of that is 8. 8 minus 16 plus 8. Well, I have 8 and 8 is 16 minus 16, so I'm getting a 0. There is my vertex. And since I know that my parabola goes upwards, that's the lowest point, it's a minimum. If I start trying to find other points and I get points down here and I'm thinking downward parabola, I know I did something wrong. I probably should get an upwards type parabola. Okay, let's just go find a few more. Remember, I asked you to find 2 on the left and 2 on the right, but we can use that axis of symmetry to mirror, so we really don't have to find 4 points, we just have to find 2. All right, let's see, what would be a good number to put in there? I don't know, I guess you could put 3 and 5 in. 3 is okay. I'm going to get 3 squared is 9 and take half of it. That's going to be something with a decimal. It's all right. There's nothing wrong with it. Let's go try it. So I'm going to put in the number 3. So 1/2 of 3 squared minus 4 times 3 plus 8. Okay, 3 squared is 9. Half of that is 4 1/2 minus 12 plus 8. So I'm looking at 4 1/2 plus 8, that's 12 1/2 minus 12. That only leaves me a half. So I put in a 3, I got out a half. I put in a 3, I got out a half. There's a point that goes on my parabola, and I mirror that on the other side. So that's going along with telling me my parabola is an upwards parabola. Let's try the number 2 and just see what happens. 1/2 2 squared minus 4 times 2 plus 8. 2 squared is 4. Half of that is 2. Minus 8 plus 8. Well, minus 8 plus 8 cancels out, so my answer is just 2. I put in a number 2, I get out a 2. So that's the point. 2, 2. And I mirror that on the other side. So there's my parabola. Got it. Let's see. If I work down at the bottom where it actually says solve, let's go figure out that solving part, because I know that was on there. And the solving part was using that quadratic formula. So 1/2 x squared minus 4x plus 8. All right, so now I'm going to actually try to solve it. I can solve it like an equation, which would be rough because it has an x squared and an x. I could try to factor it. That's going to be a little rough with that half. So I think my best bet is to do that quadratic formula. So let's go try it. So quadratic formula says opposite of b, so positive 4, plus or minus b squared, negative 4 squared is 16, minus 4 times a, which is a half, times c, which is 8, all over 2a. And 2 times a half is just 1. 4 plus or minus square root of 16 minus. What is 4 times a half times 8? 4 times a half. What's a half of 4? 2 times 8. 2 times 8 is 16 over 1. All right. Well, I get 4 plus or minus 16 minus 16 is 0 all over 1. This is actually good news. What is the square root of 0? What times itself is 0? 0. So you have 4 plus 0 divided by 1. What is that? 4 plus 0, and you divide by 1. That's just 4. What is 4 minus 0 divided by 1? 4. So that says when we solve for x, those are our x-intercepts. And I only have 1. That says that my parabola is only going to touch my x-axis at one point, at 4. And that's exactly what we have. This parabola is touching your x-axis at one place, and it is at x equals 4. So we really did the right thing here. This time the vertex happened to be on the x-axis. It's the solutions. It's not always that way, but it was this time. All right. So would you please double check and make sure that your name is on your paper? Would you pass it forward, and we'll let our substitute collect that and paper clip it and leave it for me. And I need you to clear off your desks and get ready for your quiz, please. It's okay to have a calculator on your quiz. Honestly, I don't think you're going to have it. I know that some of you will use a graphing calculator and all that, but I need for you to show me work as if you do not have a graphing calculator. Deal? If I can't see your work, then it's going to be no point. So, fair warning here, right? Okay, so when you guys have your papers all handed in, pause me for a little bit. The substitute will hand you your pink quiz. Please do not cheat off of your neighbor. There are different forms of the quiz, as usual. So pause, and you can bring me back when you guys are all done with your quiz. It's very short. Let's see if we can probably get that done in like 5 to 8 minutes, okay? Now, pause. All right, I hope that your quiz went very well and you remembered your opposite of b over 2a. Now it's time to take what we've learned about parabolas and just go with it a little bit more. I don't think you're going to find this to be super duper new. There's one part that's a little bit new, but other than that, most of this should be fairly familiar. I'm crossing my fingers that you think so. Okay, do get your pencils ready. There's a couple of things that I would love for you to write down. That would be very nice. Here we go. It says when we throw things or launch things, we call that projectile motion. Not that we throw something straight up and straight down, but we throw it and there's some distance to it as well. Projectile motion equations are always written in this form. So grab your pencils, here's what you kind of need here. We write them as y equals, because they are an equation, got it? It says negative 16t squared. This negative 16 is a number that we always use, and it is the gravity constant when we are measuring in feet. If we happen to be measuring in meters, we use a different number. But all the things that we're going to do are measured in feet. So just so you know where that negative 16 comes from, that's your gravity constant. Okay. Then we have the velocity. That's how fast the thing is being thrown, and that number gets multiplied by t. Sometimes it's hard to see that little t right there, but everything's in descending order. So the negative 16t squared, there's the gravity, plus the velocity, how fast it's going with the t, and then the number at the very end that's the constant that has no variable with it, that's the starting height. Does it start off the ground, or if it's 0, that means it starts on the ground. How high up or down does it start? Okay, so let's just first of all get a couple of minutes of practice of writing these equations. It's not that bad, just take a look and see what we've got here. Little guy throwing the ball. If a baseball is thrown with a velocity of 95 feet per second, and it starts at 4 feet off the ground, what's the equation? Well, why does the baseball start 4 feet off the ground? Because somebody's probably got it in their hand and they're getting ready to throw it this way. And this is going to be roughly, we're going to say 4 feet off the ground. I'm short, so it probably is 4 feet off the ground. All right, so let's go write this equation. All right, so we'll write y equals, remember that t squared or x squared always has a negative 16 if we're in feet. And we will be. So negative 16t squared. You can think about that like an x squared if that's bothering you, but it's a t squared or an x squared, it's just a variable. We're saying that's time. All right, the next thing is the number that goes with the t, that's the velocity, how fast this thing is being thrown. Well, how fast is it going? 95 feet per second. So plus 95t, if you'll make it look like a t so it doesn't look like a plus sign. And how high off the ground was it? 4. So do you write plus 4 or minus 4? Plus 4. All right. Negative 16t squared plus 95t plus 4. Equation done. And then later on what we'll do is we'll find our axis of symmetry and we'll figure out our vertex and we'll actually graph this thing. All right. One at the bottom. If a rock is thrown off a cliff and the velocity is 45 feet per second, and it starts at a height of 110 feet of elevation. So the rock's going off the cliff, it's starting way up in the air. What's the equation? So you take a second, see what you think. What's that gravity constant? Negative 16t squared. And velocity with the t, don't forget the t. That's the biggest thing people forget is that t. So it's plus 45t, not just 45. And then finally the constant number, how high off the ground? Started at 110. So negative 16t squared plus 45t plus 110. Did you do okay? Okay, so now when you see these equations, you kind of have an idea of what they're saying. So if you were given an equation, you could go, something's traveling at 45 feet per second, and it's starting off the ground at 110 feet. So you have an idea of what these numbers mean. Okay, just a couple of examples, and then we're actually going to work through a few on your homework page so that you get a good start on it. All right, here we go. It says a toy rocket, if you can't read, is launched off the ground and it flies with a velocity of 288 feet per second. All right, so let me read it one more time just in case you can't see it very well. A toy rocket is launched off the ground. That's what this little kid's doing. He's got a stomp rocket. He's launching it off the ground. And it flies with a velocity of 288 feet per second. So first thing is, let's go make the equation, right? You know what? Can you make the equation? You see if you can make it before I write it. Y equals, we need our gravity constant. So negative 16, that's with a t squared. How fast is this rocket going? 288 feet per second. Pretty fast for a toy rocket. 288t, and then where does it start? Does it start off the ground or does it start on the ground? Well, it says it's launched off the ground, so it isn't starting at any kind of height. So if you'd like, you can write plus 0, or you can just leave it, but you know that it's not off the ground at all. So if you're looking at A, B, and C, A is negative 16, B is 288, and C is 0. Got our equation. So now it says we're going to go sketch. When we sketch, you know we have an x-axis and a y-axis. our x right now is kind of being replaced with t, and that's standing for time. So this is what happens as time goes on. And this also says the y value, when we put numbers in for time, we're finding how high this thing is going. So this is the height. So as time goes on, what we're finding the height of the rocket. All right, so when time is 0, where is the rocket? It's on the ground, okay? And you know that this rocket, as time goes on, when it gets launched, it's gonna go up in the air, and then at some point, it's gonna come back down, right? So as time goes on, I don't know exact numbers right now, but I'm gonna take a guess. At 1 second, it's going up, and at 2 seconds, it's going up, and at some point, it's gonna be the highest possible, and then as time goes on, it's gonna come back down, and it's gonna crash back down on the ground. So height goes up, height goes down. All right, let's go see if we can answer these two questions here. It says, when does the rocket reach its maximum height? When does it reach its maximum height? Well, I'm just looking at my sketch graph, and I'm thinking maximum height. I'm thinking that my maximum height is the very tip top of my parabola, and you have a word for that. That's your vertex. So if we can find that vertex point, I bet we can figure out when the rocket reaches its maximum height. Let's go do it. So you remember what to do to figure out the vertex? We got to get that axis of symmetry first, so let's go do that. X is opposite of b, so negative 288 over 2 times a, which is negative 16. All right, negative 288 over negative 32. Okay, you know what? I think I'm going to have to grab a calculator on this one. I can do some math in my head, but I can't do that. Okay, so I'm dividing 288 divided by 32. I'm not bothering with the negatives because you know negative divided by negative is a positive, and I'm getting 9. Did you guys come up with 9? So I know that is the x value, or in this case, the t value of my parabola, of my vertex. Can't talk. All right, 9. Actually, you just answered a question. When does the rocket reach its maximum height? Well, we just went 9 seconds over. I don't know the height yet, but that 9 says you go over 9. I'm not sure how high up yet, but we just went over 9. We went 9. Now, did you go 9 minutes, 9 hours, 9 seconds? How do you know? Back in the problem, you were going feet per second. So it's telling you that your time is in seconds. So you just figured out 9, oops, I was going to write 9 feet, 9 seconds. Got it. Now, if you want to find the maximum height, we just have to keep going on this vertex and find the y value. And you know how to find the y value, right? You've already got the x value. Go put it in your equation. So I have the equation negative 16t squared plus 288t plus 0. I'm just going to replace the times, that x, that t, with 9. Negative 16 times 9 squared plus 288 times 9. All right, remember on your order of operations, do your 9 squared first. So in my calculator, I'm pushing in negative 16 times 81. And then plus 288 times 9. All right, what are you coming up with? I have 1296. Do you guys have 1296? And I'm pretty sure that I am in feet. So 1296. Oops, didn't leave myself enough space. But you see what I'm doing? If I find my vertex, which you already know how to do, then you know the time of that maximum height, and you know the maximum height. That's what these numbers are. How long did it take, and how high did it go? Got it. Okay. Not everything is going to ask you about a vertex. If it asks you about maximum height, that's definitely a vertex. Every now and then they're going to ask you about when does it hit the ground, and that's going to be an x-intercept. So pretty much there's going to be 2 things that they'll ask you. They'll ask you about a vertex, or they'll ask you about an x-intercept. Let's go try another one. All right. So this one says, Sophia tosses the basketball with a velocity of 22 feet per second. You know that's an important number. She releases the ball when it is 3 feet off the ground. Okay, so can you take just a second, or 2 or 3, can you go write your equation and then just kind of make a little quick sketch? So I'll step out of the way. pause the video for a second. See if you can write your equation and your sketch. Ready? Go. Okay, let's go see if I can do it just as well as you. So my equation is y equals negative 16t squared. The velocity said 22, so 22t, and it was 3 feet off the ground, plus 3. Does that look like your equation? Question usually comes up, is it always negative 16t squared? If you're in feet, yes, and we're always going to be in feet. So yes, it's always going to be negative 16. All right, so my sketch says, down here, here's time. As time goes on, what's the height of the basketball? All right, so I always kind of take a look about what happens when time is 0. When time is 0, does the basketball start on the ground? No, it does not. The basketball starts 3 feet off the ground. So I'm going to make sure that I'm starting 3 off the ground, and then the basketball gets tossed up, and then the basketball comes down. Okay, so I do have a parabola here, but my parabola is not exactly going at 0, 0. Still okay? All right, here we go. Let's figure this out. When does the basketball reach the maximum height, and when does this maximum height occur? So these questions are about the maximum height. If it's about maximum height, they're wanting that vertex. So let's go deal with vertex. Okay, you know how to find a vertex, right? We're going to get the vertex, and then we'll figure out what number is what. How's that? Okay, vertex, x is opposite of b over 2a. What's my opposite of b number? Negative 22. 2 times a, and a is negative 16. So I have negative 22 over negative 32. Well, a negative divided by a negative is definitely going to be a positive, and I'll take 22 and divide it by 32. I have kind of an icky decimal, but I'm just going to leave it, actually, I think, or you can turn it into a fraction. I have 0.6875. It's not that long of a decimal, and it doesn't go on forever, so you can leave it. That's okay. If you turn it into a fraction, you hit the math button, and then it already says like arrow fraction. That's 11/16. So either one is completely fine. But I am getting 0.6875. So not even 1 second later. Close to 0.7 seconds later, but not quite, right? All right. So there's 0.6875. Don't round it. It's not that long of a decimal. Let's go find the y value of this vertex. So I'll take negative 16. I'll do 0.6875 squared plus 22 times 0.6875 plus 3. Had to squeeze that one in. All right, and now it's just a calculator problem. I can't do that off the top of my head. I just have to be very careful about how I put it into my calculator. Okay, I also have a decimal. I wish I came up with a pretty number, but I didn't. I have 10.5625. It's fine, it's not that long of a decimal, just go ahead and leave it, it's okay. So, you have these two numbers. You have 0.6875 and you have 10.5625. That's the vertex point. The 0.6825 is like the x or the t, and the 10.5625 is your y value. So this point is 0.6875 and then 10.5625. So of all of those numbers, of those two numbers, which one is when? When is it the maximum height? Well, we went over 0.6875, then we went up about 10.5. Over is your time number. So 0.6875 seconds is when, and what, when does Royal Beach's maximum height? Oh, it says when does it occur, silly me. Let's go change that question to, so what is the maximum height? Maximum height? Well, I already know, don't I? 10.5625 feet. I just asked you the same question twice. Oops, sorry. Okay, now I know you've got decimals, but that's what calculators are for. That's what your Desmos is for. Not a problem. Thing is, do you know what to do? All right, let's go see if we can figure out a couple off of your homework. So we're actually going to start a little bit on your homework. So if somebody would be very kind, there's some kind of cream-colored pages over here, and and pass those out. You can pause the video while we do that. Looks like this. Okay, so pause me for a second and go pass those out. There is an example problem, and then there are 6 problems on here. So I would love to get through the example problem and problem number 1 together, and then you guys have the rest of the time to work together and get the other problems. Okay, let's go see what we can do. And that's why this is all blank, so we can do this example problem. So at the top of your paper, go ahead and put your name on there. There is room to write on it, but if you feel better with your own paper, that'd be great. So the example says, in Acapulco, Mexico, drivers leap from a cliff 8 feet per second into the Pacific Ocean 87 feet below. The rocks extend 21 feet from the starting point. The diver has got to go out 27 feet to land safely. So A says, let's draw a picture. Let's draw a picture. Yeah, no knocking my drawing skills here, right? So we've got the guy on the cliff. He's going to go cliff diving. There's some water. I know it looks like he's on a boat. Just go with it. It says that there's some rocks extending out from the bottom. So here's my rocks that he needs to go jump out past. Okay, let's put some numbers on there. How high up is this jumper? I see numbers. I see 8, I see 87, I see 21, I see 27. How high up is he? It says the ocean's 87 feet below. So that means this height is 87 feet. Okay, so the guy is starting 87 feet up in the air. He's got to jump out a ways, correct? So this is your parabola here. He doesn't jump up, he just starts here and kind of jumps down. And the base rocks extend 21 feet away, and so he's got to jump out here to 27 feet. Hard to put 8 feet per second on there, but that's how fast he's going. So that's kind of question B. What's the equation that describes the jump? Remember, negative 16t squared. How fast is he going? He's going 8 feet per second. And now what? How high up does he start? 87 feet. All right, we've got our equation, so we can figure pretty much anything about this guy. It says, actually, I'm going to skip C for a second. I'm going to go to D. Are you listening? I'm skipping C. I'm going to D. It says, what is the maximum height of the dive? Let's go figure this out. So the guy's here. My guess is he's not just going to fall down into the water. He's going to jump up and out a little bit. So we're going to figure this thing out. How high up? That means I need to figure out this maximum point. Maybe he's at the maximum. My guess is probably not. So let's go find the vertex point. If it's ever talking about a maximum height or time, then that's your vertex. So you know how to do that, right? So I'm on question D. X is opposite of B over 2 times A. So I have negative 8 over negative 32. 8 over 32. 8 over 32 is 1/4, so I have 0.25. It takes him 0.25 seconds, that's the X part, right? 0.25 seconds to get to the maximum height of his dive. He jumps up, and then a 1/4 second later he's at the height, and then he starts falling. That's okay, let's go find the maximum height of the dive. So I'm going to put 1/4 or 0.25 back into my equation. Negative 16, 1/4 squared plus 8 times 1/4 plus 87. All right, go put this one on your calculator. I think you'll be okay. 1/4 squared, in my head I know is 1/16, and I'm timesing by 16, or negative 16. So there's a negative 1. 1/4 of 8, that's 8 divided by 4, that's 2, plus 87. So I'm getting 88 feet. Did you guys get 88 feet? Okay. Hopefully that kind of makes sense. He's 87 feet up in the air, he jumps, he only goes a little bit, he's only jumping up a foot or so, and then he starts falling back down. So, there's question D. What is the maximum height of the dive? Got it, 88 feet. All right, so there was question D. Got that one. I'm gonna erase, and let's go see if we can hit question C. So question C is a little bit different. We haven't done this one yet. It says, when does the diver hit the water? So the diver hitting the water, that is not a vertex, is it? That's going to be an x-intercept. If you think about this as like your x-axis, here's your parabola, here's an x-intercept, and here's an x-intercept. we need to find our x-intercepts. X-intercepts are when you set your whole equation equal to 0. We're solving. So I'm setting my whole equation equal to 0. Now you have a choice. We can factor it like normal. We can use box method because you have a negative 16, or we can go for quadratic formula. Box method wouldn't be too bad, but if you remember, we'd have to do negative 16 times 87 and get all those factors, and that's probably going to be pretty. So let's go ahead and do quadratic formula. All right, negative b plus or minus square root of b squared minus 4 times a times c, all over 2a, negative 32. All right, negative 8 plus or minus 64. Now I've got my 64 on here. I need you to look with me at the plus or minus. You have a negative 4 times a negative 16 times a positive 87. What's a negative times a negative times a positive? A positive. It's going to be 64 plus something, not 64 minus something. All right, so I'm grabbing my calculator because I can't do that in my head. 4 times 16 times 87. Oops. 4 times 16 times 87. All right. 55, 68, all over negative 32. Negative 8 plus or minus square root of, I'm adding 64 with it, so my discriminant is 56, 32, all over negative 32. I'm trying to see if it is a perfect square, and of course it is not, but that's okay. Go ahead and square root it. We're not going to do square root jail on this one. Go ahead and get a decimal. It'll be fine. So I'm coming over here. Negative 8 plus or minus. What is the square root of 5632? I have, if I round it off, I have about 75.05. So I'm writing 75.05 all over negative 32. Now we've got to figure out these two numbers. So here we go. Negative 8 plus 75.05, and then we'll divide it by 32. Remember, get the whole numerator first. So negative 8 plus 75.05, hit the equals button, then divide by negative 32. So one of my answers is negative 2.09. So we did the negative 8 plus. Now let's do negative 8 minus. So negative 8 minus 75.05, hit the equal sign, divided by negative 32. Then I have 2.59. So there are two answers here. Now the question is, which one? Remember, these are your x-intercepts. You have roughly negative 2 and roughly 2.6. So negative 2 is the parabola over here. The 2.6 is the end of the parabola over here. So when does he hit the water? Not the negative one, it's a positive one. He hits the water at about 2.6 seconds. So this is the one that I want. I don't want the negative one, I want the positive one. So if it ever asks, when does it hit the ground, it wants a time and it wants an x-intercept. And you may have to do a quadratic formula for that. More than likely it's going to be quadratic formula. All right, let's go on to question number 1 so we can do number 1 together. I have a feeling I'm going to have to pause for just a second, a minute here. Actually, you know what? Tell you what, why don't you guys take a look at number 1 really quick. It says, draw a picture depicting the situation. There's a flare going from a life raft, and what is the quadratic equation that models this situation? So, can you get those two questions done? Draw the picture, and what's the quadratic equation? Okay, pause me for a second, and then you can come back and check my work. Sound good? Okay guys, the battery's running out, so I gotta go really fast on this one. Sorry. Okay, picture, flares launched up, comes back down, right? Time, height. Let's see, it's launched from the life raft, so it's not exactly on the ground, but it's sea level, so we can kind of consider that on the ground. Let's see, y is negative 16t squared. The velocity is 144 feet, so 144 t. And if it starts at the ground or sea level, then we've got plus 0. Check. I hope your A and B are good. So I'm skipping to, actually I'm going to go do C just in case this battery runs out. How long will the flare stay afloat, to stay aloft? That means how long is it in the air? They want this time. So finding that time, anytime you want an x-intercept, that's using your quadratic equation and solving for x. You are more than likely going to get two answers. There's only going to be one that really is going to be yours. So let's see. Opposite of b, negative 144, plus or minus square root of b squared. Not a clue what 144 squared is. 20736 minus 4 times negative 16 times c. c is 0, all over 2a. So I have negative 144 plus or minus. Do you notice when you have 4 times the 16 times the 0, all of that end is going to turn to 0 and you just have 20736. So you have negative 144 plus or minus the square root of 144 all over negative 32. Sorry. If you do the plus, negative 144 plus 144, 0. 0 divided by negative 32 is 0. Negative 144 minus 144 divided by negative 32. 0 and 9.
I think your lights are on again.
So if you're between 0 and 9, how long does it stay afloat? 9 seconds. All right. If you, because like I said, I think this battery is going, if you need to find the maximum height, then we're finding our vertex, right? So vertex, x is opposite of b over 2a. Negative 144 over negative 32. Let's see, 144 divided by 32. 4.5.